Welcome back, guys. So I've already introduced digital logic systems, and in this video I'll be talking about our first topic in the subject, which is flip-flops. So memory are called flip-flops, and you can also call it registers. So in this video we'll be talking about SR flip-flops, and this is our circuit. This is our circuit for SR flip-flops. It's SR flip-flop circuit. Yeah. So this is SR flip-flop circuit, and we'll be constructing the table. I supposed to explain how to construct the table. You can construct the table from this circuit, but in this video I'm not going to be explaining how to construct your table from this circuit because it will take time. But I will be showing you, because I told you in the introduction that I'll be giving you shortcuts on how to solve questions on this particular course. So let's be constructing the table. We have S of t, R of t, Q of t, Q of t plus 1. So and we have this. Yeah. So in digital logic design, not digital logic system, in digital logic design, I'm sure you know how to convert a value to logic, like 0, 1, 2, 3, 4, 5. For 0 we have 0, 0, 0, because this is 3-bit. We have 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So this is 0, 1, 2, 3, 4, 5, 6, 7. Yeah. So this is what we have, and this is our present state. This will be our next state. So I think I have to underline this so that you will understand better. We have this block and this block. So these are blocks. So here the shortcut is getting it from this from the circuit is somewhat complex. That's why I just want to give you the shortcut. The first thing you have to do with SR flip-flop table is to check our present state. Here is 0. The next state will also be 0. Present state is 1. Next state will be 1. So this block here, the copy of the present state is the next state. So there's no change. So here we can write no change here. No change. So there's no change in the states. Then the next one, the next block, which is this one, will reset. Reset means changing the value to 0. It will be 0, 0. So we reset this. So this is the second block. We reset. Reset. So the next block we set. Set means changing it to 1, because reset means changing the value to 0. But here we are setting. So it will be 1, 1. So we set here, and the last block, which is 111, which is 7, this place is undefined. So it's undefined. That's for SR flip-flop. So this one is undefined. So this is the table for SR flip-flop. And the next thing we'll be doing now is to find our characteristics table and also the excitation table. So let's do that very fast. So let's write this thing out again. We have SR Q of t plus 1. So we have 0 0 0 1 1 0 1 1. So for the characteristics table, here we have, as you can see, we have this our present state and this our next state. Here we have 0 1 0 1. There's no change here. That means the present state is the next state is the copy of the present state. So there's no change there. That means Q of t plus 1 will be Q of t. So this one will be Q of t. As you can see, there's no change in the present and the next state. That's the reason why we are calling this one Q of t. 0 0 1 1, no change. Q of t is equal to Q of t plus 1. So there's no change. So the next block, which is this, we have 0 0 1 0. We are resetting here. I told you in the when I was constructing this table that reset means changing the value to 0. So we are resetting. So this one will be 0. And the next block is this. We have 0 1 1 1. We are setting. So that is setting means 1. So this one will be 1. And the last block, let's look at the last block, which is this, is undefined. So it's undefined. So that is our characteristics table. Let's write it here. Characteristics table of SR flip-flops. And this table we constructed here is called it's called the truth table. Truth table of SR flip-flop. So this is our characteristics table of SR flip-flop. Now the last table you need is excitation table, and you construct your excitation table from characteristics table. Let's write this down again. Q of t, deal with this, Q of t and Q of t plus 1, and we have SR here. So this is what we have. This is what you have to write for you to be able to construct your excitation table. So this is what we have so far, and we have 0 0 0 1 1 0 1 1. So now the first thing you have to do is to separate them. We have 0 0 here, because in this block we have 0 0, in this block we have 1 1. Q of t is 0 here, Q of t is 1 here. It's not changing here. So after constructing this table, then you will look to your characteristics table, and here Q of t is 0 in this block, as you can see, is 0 here. So you make this one 0 here, because Q of t is 0 in this block. You make this one 0 here, and this one is still 0, this one is still 1. Now what's Q of t plus 1 here is 0. It's 0 here. Q of t plus 1 is 0 here. So you look at where Q of t plus 1 is 0 here. Let's see. It's 0 here. As you can see, it's 0 here. It's also 0 here. We have this and this, 0 and 0 here. So we look at it. What is S? When Qt plus 1 is 0 and 0, S is 0 0 and R is 0 1. So that means S is always 0. S is always 0, and R is changing from 0 to 1. As you can see, this is R. It's changing from 0 to 1. So we don't care about it. Don't care. So that's the first step. Then the second one is to look at this place. What is Q of t plus 1 here? It is 1. So look here for where Qt plus 1 is 1. It is 1 here, just this place. Others we have 0. Q of t is still 0, because we are still dealing with this block here. So it's still 0 here. So since it's still 0 here, we are not changing it. Now Q of t plus 1 is 1 right now. Where is Q of t plus 1 1? It is 1 here. As you can see, it's 1 here. So we only have 1 here. Others we have 0 0 and undefined. So we have 1 here. Let's look at it. 1 0. So you come to your excitation table, you write 1 0 here. Then that's all for this block when Q of t is 0. Now Q of t is 1. Q of t has changed to 1 now. So we have to change our Q of t here to 1, from 0 to 1, and this one still remains 0, this one is still 1, this one is undefined. So here, let's look at Q of t plus 1. What is Q of t plus 1? Is 0 here. As you can see, it's 0 here. Let's look into our characteristics table again. Where is Q of t plus 1 0? It is 0 here. Just here. This where Q of t plus 1 is 0. Just this place. So let's look at it. We have 0 1. So you come to your excitation table, you write 0 1. Then lastly, we have Q of t plus 1 here. It is 1 here. Q of t plus 1, which is the next thing, is 1 here. So let's look at our characteristics table again. Where is it? 1. So Q of t plus 1 is 1 here. It's also 1 here. So let's look at it. It is 1 here. It is 1 here. And it's also 1 here. As you can see, 1 1. So what is our S here? We have 0, we have 1. So S is changing. That means we don't care about X because it is changing. Then let's look at R. What is R? We have 0, we have 0, we have 0. So R is not changing. It is 0. 0. As you can see, this is our excitation table, excitation table of SR flip-flop. Yes. So that is how to find the characteristics table of SR and also excitation table of SR. Now let's look at our table again. What have we done so far? We've talked about SR flip-flop, and we said this is the circuit for SR flip-flop. This is the circuit for SR flip-flop, and this is the table for SR flip-flop. We have this place no change, in this block reset, in this block set, in this block is undefined. And we talk about the characteristics table of SR flip-flop and also the excitation table of SR flip-flop. So in the next video, I'm going to be talking about JK flip-flop. So just go over it again. It is very easy. In the textbooks, they don't give you shortcuts like this. They'll just tell you the steps to use, but here, or the methods to use. But here, I gave you shortcuts on how to construct your characteristics table and also your excitation table. So thank you guys for watching. In the next video, I'll be talking about JK flip-flops.